I'm in RSA. RSA is the security division of EMC, so I'm working in providing machine learning-based solutions for cybersecurity. I'm going to talk about cybersecurity, and then it's slightly about big data, and then machine learning, all in 20 minutes. So this is the cybersecurity paradigm. You have your own enterprise and all the devices connected in the internal network, and then comes the attacker, and the attackers try to penetrate the network with some infected malware, and then one device gets infected because you go through your unsecured website. And then these what we call lateral movements, so we try to affect other machines, other server, and then he finds what he was looking for and extracts the data. So this is how an attack basically looks like. And the cybersecurity paradigm looks basically like this. So we'll build a wall, a big wall between the internal network and the scary outside network. How many of you are Game of Thrones fans? Very quiet. Oh, thank you. Okay, so this is like the wall. Okay, it's not an ice wall; it's a firewall, and this is the main paradigm for cybersecurity. And the reason I know it is because around 80% of the budget goes to these applications: firewalls, antiviruses, things like that. And this is a very cool solution. There's only a slight problem with it, and it goes that you try to attack, you get into the wall, and even if some device is infected, you can't extract the data because, again, the wall blocks you. And the problem with this solution is that it doesn't actually work. So these are all from last year, published breaches, and what you can see here, these are not small companies. This is a big company. They put a lot of money into cybersecurity, and they buy the best of breed solutions, and still they're getting breached. And the reason is that it looks a bit like this. So they keep the gate closed, but it's not very difficult to get inside. So let's move to this metaphor. So what I'm going to do if this is how my backyard looks like. So maybe I'll put some security camera, or some flashlights, or some motion detection, or a dog, and my favorite, a tripwire. So all of these can help me in protecting my backyard. But what they actually give me is visibility. So the gate is still very narrow, but I know what's going on there. So moving back to cybersecurity and to the wall, which is not that solid anymore, this is what we're heading towards. This is what we're trying to do. So we know there are attacks. We know the wall is not as strong as we would like it to do. And we try to understand what's going on in our network. So we look at all the data, all the communication that gets inside our network, and we store it in some database, and we look at everything that's going on within our network. That's a lot of data. And again, we store it and everything that's going out. And behold, this is big data, right? So we have variety because a lot of different data sources, network, net flow, log devices, and logs of servers and devices, etc. We have velocity because all of these are very verbose. They talk a lot. They give us a lot of information in a high rate, and of course, volume, because we want to store a lot of information for a month of history, so that it becomes petabytes for a medium-large company. So now we have all this data, and we hope we have some visibility. And the theme now becomes not just try to block everything, because we can't block everything. What we can do, or hope we can do, is to monitor most of the things. So we monitor a lot of data and all the communication, everything that goes inside, everything that goes outside, and we analyze everything there. And hopefully, if we monitor most of the things and we analyze smart enough, we can detect everything bad that's going on in my network. Unfortunately, or luckily from my perspective, this is a lot of data, so we can't actually put a lot of folks in the Indian office we have and ask them to go over the data. So we need some automatic tools to go over the data. So this is data science. So it used to be called machine learning, or used to be called data mining, but it's all the same. Some automatic tools that go over the data, extract the bad alerts or the attacks, and put aside all the benign communication. And now we can detect everything. So obviously, and everybody's talking about it, this is the next step. The solution for cybersecurity and for the lack of security in our system is through data science or machine learning. And this is cool. And again, there's a slight problem with this, and except from the too large font. And this is that if you look at actual products, and again, best-of-breed products for cybersecurity for enterprises, they don't have or they don't integrate yet machine learning and data science solution within these products. Put aside all the brochures. If you look at the brochures, everybody's doing data science, and they're extremely successful with this, including our own company, by the way. But when you look at the actual products, either you don't have data science at all, or you have only the beginning of data science. As I told you, I work on cybersecurity, and I work on data science application, and we do have data science in our own products. But it's far from what we can do, and it's far from what we want to do in the upcoming years. So the question is why? If we know that data science or machine learning is the answer for cybersecurity, and companies are willing to pay a lot of money over this because breaches are very hurtful, so why we don't have data science, and why is it still so difficult to integrate into the system? Sorry?
Where are the people?
I'm one. Yeah. So we don't, I'm working in a large American corporate, so we don't have problems or drawbacks, we only have challenges. So here are some of the challenges of why data science is difficult in cybersecurity. So we start with anomaly detection. All of you heard a lot about anomaly detection over the last few hours. I didn't hear anyone mentioning that anomaly detection is difficult. When you look at machine learning, you basically have two approaches, pattern recognition and anomaly detection. Pattern recognition is when you don't know what you're looking for. You're looking for specific patterns. It's not that difficult. It's not that easy to find them all the time, but at least you know where you're heading. Here in cybersecurity, I'm very less interested in the attacks I'm familiar with. Those are the ones that are easy to block. I'm much more frightened of not knowing things, of the attacks that I'm unaware of, all the 0 days, all the new vulnerabilities. So I can't really afford to look for the things I know, so go to the pattern recognition approach. So the only other approach is anomaly detection, meaning I'll try to profile the regular behavior, as was demonstrated in previous lectures, profile the regular behavior of users, of servers, anything that is anomalous, hopefully might be also malicious. But anomaly detection, by its essence, it's much more difficult than pattern recognition. It's much more difficult to look for things that I'm not aware of than to look for things that I am aware of. And there's the high cost of errors. So look, for example, on Amazon recommendation engine. So you go to Amazon, you buy a book, and you get a recommendation of 5 other things you might be interested in. And in some cases, you're indeed interested, and you go and buy another one. And in some cases, you're not interested, and in some cases, those are entirely foolish. And the cost of error here is negligible. It's some sour user experience, but I'm OK with it. I don't really mind the recommendation engine to recommend some not interesting options. If I'm missing a security breach, someone is attacking me and I don't detect it, and the cost can be very significant, starting from system failure, data that is being stolen, moved to my competitors, and mostly in reputation, it might get to tens of millions of dollars. So I need to be very accurate. This is not only from this type of error, there's also the other type of error that something is benign and I detect it as error. Because I have so much data, I can't really afford myself to alert all the times on false positives, because at the end there are a limited number of analysts that need to go over the data. So every error is very painful. Data is not public. So in many areas in machine learning, there are all these brilliant guys in the academy. There are a lot of interesting stuff. Most of it is far from being relevant, but occasionally you stumble upon some interesting paper and you think, okay, this is something I would like to embrace and implement some sort of it in my system, change it just enough to patent it. But we can rely on all the advanced features that's going on in the academy. But here, the academies don't have data. The data that we're working on is communication, internal communications and emails and documents you're working on, and these are all very sensitive and very personal. So companies very rarely publish this data, and the researchers don't have a lot of data to work on. So DARPA did or published a large data set at 1996, and then 3 years later, 1999. And still today, every year there are tens and hundreds of papers that are published that refer to this data set. So think how different our situation is from 20 years ago to now. There are no smartphones, no Internet of Things, no cloud, but still this is a huge data set that everybody's working on because you don't have a lot of available data sets out there. The semantic gap here and detection is not enough. So you see a lot of machine learning systems that are very good and the output is some sort of anomaly. But the output here needs to go to some human analyst and it needs to be comprehensible and understandable, something you can work with. So just saying that I have an alert because the network communication now is 2 standard deviation above the normal average doesn't tell a lot to the analyst. You need to have alerts that are stated in security language. What is going on? Someone is breaching my system, some data is being stolen, some privilege escalation, a user is doing something he's not accustomed to, and there's this breach and the semantic gap between the output of the machine learning system and the input that the actual analyst needs to do in order to further investigate. And the gap is between the researchers that understand machine learning and the analysts that understand security. And as you mentioned, there are not that many individuals that understand both domains that can speak the 2 languages, the machine learning language and security. And there are evaluation difficulties. So let's assume I got over all these drawbacks or challenges, and I have this beautiful model, and I think it works really well because I designed myself, and the algorithm is very cool, and now I need to evaluate it somehow over real data. And there are 2 major issues here. One, that might sound funny, but we don't have enough attacks. So we at EMC, it's a large organization, we get attacked every day, 10th of attacks, probably more. But these are very low-level attacks, not the attacks that I'm interested in, and they're very easy to block. I'm interested in the country-based organization that is trying to attack us, or the criminal organization, something highly funded, very experienced, very talented, and these attacks don't occur very often. They happen every couple of years or more. So I don't have enough real attacks in my data that I can actually evaluate my system on them. And even when I do have attacks, I don't have enough of labeled data. So I have a lot of data in my data sets, in my databases, but nobody comes and labels this as benign events or malicious attacks. So we do have analysts, but still, this is not enough. The data by itself is unsupervised, unlabeled, so it's very difficult to evaluate. And I need to figure out some clever way of how to evaluate the system without labels on the output. And the last challenge here is the adversarial environment. So one of the main reasons for using machine learning is that things are adaptive and change and personal, and you need systems that can adapt. That's obvious. But our systems don't only adapt, they adapt against us. Because we have adversarial opponents on the other end, and we build our defense and they build their attacks. And they see what we're defending and how we're defending, and they change their attacks accordingly. So the environment not only changes, it changes against us. And humans are very, very good in pattern recognition. We do it every day. Just compare how we do face recognition, how we do image understanding, how we do natural language processing. All of these are tasks that were and still very difficult for machine learning automatic tools. But humans do it very easily. So adversarials here can try and understand, and they're very good at it, and understand the patterns that we're looking for and the ways that we're building our defense systems, and they accommodate to it, and they change their attack patterns. I used to have 2 more, and actually that was about the end of my lecture when I previously about it, but then people told me that it's kind of depressing. So I kept myself to only 6 challenges, and now I want to show you the other side of the coin of why we do think that machine learning can assist and actually is inevitable in cybersecurity solution. So let's start backwards. So we do have adversarial environments, and they do try to change, and people are very good at pattern recognition. They are, however, very or less good or less experienced with multivariate systems. So if I have a system that has 3 or 4 features, it's not so difficult for a human to understand how it works. And the key number here is usually 7 plus minus 2. So if we have a rule of 7 or no more than 9 different features or different items in it, so people can understand it and understand the logic behind it and then maybe understand how to go over it. But people have a hard time dealing with hundreds of features or thousands of features. So if I'm building a system that has so many features, it's very difficult for a human adversarial to understand what's going on and what's the logic or algorithm behind the system. And from the system perspective, it's exactly the opposite. The whole base or the whole perspective of machine learning is to extract a lot of meaningful features from the data, a lot of information that makes your model much more powerful and helps you to extract insights. So we want to make as many features as possible and extract a lot of information as much as we can. This simultaneously makes our system more powerful and also makes them difficult to override. We have evaluation difficulties. So we try to overcome it. We do have some case managements, and in our company, in EMC, we have analysts, and we have centers that go over incidents and try to label them as false alarms or actual attacks. And we communicate with them, and we get all this feedback. So we do have some labels. It's not enough. It's far from being over all the data, but we have a lot of labeled data, much more than nothing. And also, we can put some honeypots and try to detect attacks to specific places, and then everything that goes in there, we know that this is an attack and we can get more labels. As for the semantic gap, what we try to do here is to combine or make the machine learning researchers and the security analysts work together. So instead of having these researchers work here and the analysts or security guys work on a different office, we build groups and teams, and we force these people to work together and understand each other, and then we can derive systems that are strong both from the machine learning perspective, but the outcome is understandable for security guys. Yes, data is not public. When I give similar talks in academic conferences, this is the haha point, because there is no data in academy, there's a lot of data in the industry. And this is one of the few cases that the data is located in the industry and not in the academy. So companies do not share information, they don't share data or are very reluctant to. But I have my own company. So EMC is quite a large company. We have 70,000 employees over 87 countries. That's a lot of data. And all this data is gathered to some local data center. So we have about 2 billion events per day and a lot of network traffic. We have a lot of data to work on. Not all the data we'd like to, but data is not a real issue from our perspective. And the last two, the high cost of error, the anomaly detection. And the short answer here is that this is indeed a difficult question, and we need good researchers in order to do good anomaly detection and to provide an extremely low false alarm rate. The long answer is that, at least from my perspective, this is what makes it interesting. And this is why I love cybersecurity, and maybe some of you also, and I invite all of you to join us in our journey in cybersecurity, in providing machine learning for cybersecurity, and in brackets, we are also hiring. So these are difficult questions, but solving easy question is kind of boring. So I want to solve difficult questions. I want to be challenged. I want to have to be creative in order to solve these challenges. So yes, it's difficult to do anomaly detection. It's difficult to provide good solutions, and that's why it's interesting. So before I finish, we talk a lot about machine learning or about data science, but data science actually is not a role. There's not one data science. It's more like a group effort, and it's combined of 3 different positions. So we have the data maestros. This is always a big data issue, so we need the guys that will know MapReduce and will know to work with Hadoop and extract all the data and know how to manipulate it and extract features from it. And this is very difficult, and in many cases, I provide some sort of algorithm, but we need to make it run in parallel and distributed. This is a trivial task. It's not programming. It's much more than this. We need a domain expert. So this is far from being plug and play. It's not that I have an anomaly detection problem, I design some algorithm, and voila, this is the answer. We need to tune for the specific domain. We need to understand a lot about the use cases, about security, about attacks, about what the attacks are after, about how networks are built and work. So we need to have domain experts that work with us and explain a lot about what are the features, how to evaluate what models are good or bad, how the output should look like. And of course, we have the machine learning researchers. And only when we combine all of them together, we actually get the science with a too large font. And this is what we do basically in our side. We have a group that combines both data maestries and domain experts, used to be called hackers, and machine learning researchers. And that enables us to do a lot of, I might say, very cool cybersecurity machine learning applications on many, many use cases. This is my email. If any of you want to get more information or are interested, please email me. Thank you.